Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count number of good subarrays. And the problem states that we are given an integer array nums with an integer k, and we want to return the number of good subarrays of nums. So a subarray is good if there was at least k pairs of indices with ij, that I is always less than j and the two elements are equal. So if we look at this example, we return 1 because there's 10 ways to pair up the indexes with equal values, and that will require the entire array itself, so that's the only subarray, so we return 1. And if we look at this example, there's 4 ways to have good subarrays. This is the first one because 2 and 3 occur twice. This is the second one because 2 and 3 occur twice and 4 also occur twice, so it has 3 pairs. And this subarray also works because 2 and 4 occur twice. And this subarray also works because 2 and 4 also occur twice. So now that we have seen some examples, let's get to how we can solve this problem. Before we get to solve the problem, I hope we can see some patterns here. So if we have 1 same number, we form 0 pairs, 2 same numbers, we can form 1 pair, 3 same numbers, we can add 3 pairs, and 4 same numbers, we can add 6 pairs. So as you can see, when it's 2, we just add 1 to 0, and when it's 3, we will add 2 to 1, and when it's 4, we will add 3 to 3. So we just add the previous number to the previous number of pairs, and that would be the pattern that we can use to solve this problem. So one way that we can solve this problem is we can have a left and right pointer start at 0, and we will keep shifting the right pointer until we find a valid subarray. And once we find a valid subarray, then we will subtract the length of the array to the right pointer, because let's say if this is a valid subarray here, then that implies that this would be valid and this would also be valid. So there would be 3 valid subarrays from here if this is valid. And once we find a valid subarray, then we will shift the left pointer and we will continue shifting left until it becomes invalid, and then we will shift the right pointer again, and then we will continue this loop until the right pointer and left pointer have both shifted all the way, and then we will return the number of subarrays that we found as a result. So let's go over this example real quick. So first we will set the left and right pointer both to 0, and we need to add 3 to count. Now right pointer shifts over, add 1 to count, but if it's 1 pair, we don't add anything to the same because it cannot form any pairs. Now shift over again, still nothing, shift over again. Now we have 1 same pair because 3 and 3, they occur twice, but same needs to be greater than or equal to k to be considered as a valid subarray. Now we shift over again, add 2 to count, but still nothing. Now we shift over again. We see that with this window, we can form 2 same ones because we will subtract the length to the right. So 7 minus 5 is 2 because these 2 can form a valid subarray. So we add 2 to result. And now we need to shift the left pointer. It is no longer valid, so we shift the right pointer again, and we see that right here it can form 1 valid subarray because 4 appears twice and 2 appears twice. So we add 1 to result, and we shift the left pointer again, and we see that this is also valid subarray, so we add another 1 to result. Now we shift the left pointer, no valid subarrays here, shift again, no valid subarrays, shift again, no valid subarrays, shift again, and we're done. And the result is 4. So the time complexity would be O of n because we need to loop through the nums array, and the space complexity will also be O of n because of the count hash map that we made. So now let's get to the coding part. So first we will set the same variable to 0, and we can actually start right as -1, and then we will make a counter hash map, we'll call it CNT, and initialize result to 0. And now we'll iterate with the left pointer, so while left and range length of nums, and while same is less than k and the right is less than length of nums minus 1, then we can increment the right pointer, update the same, and also update the count hash map. So count of nums are right, and then count of nums are right plus 1. And afterwards, if same happens to be greater than or equal to k, then we can update the result, and we will take the length of nums minus the right pointer. And then after that, then we can shift the left pointer. So we will -1, and then we also need to decrement same by whatever was on the nums of left. and then we can return result in the end. See if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any other questions or comments, feel free to leave them down in the comment section, and I hope to see you all again soon.